Okay, changing the subject to our favorite protocol. I got the t-shirt and everything. Same thing applies, guys. This is the first time I do this. It is work in progress. It's also the type of content that we are going to put in the public domain, and you guys are the test audience. This time it's about the NetConf protocol. All right, same thing here. This presentation uses, in this case, actually a set of common kind of network-oriented tasks that people that run networks do to walk you through the features of the NetConf protocol. So you'll see a commonality here, is that we wanted to try to do presentations or tutorials that are just not going through RFCs top to bottom, but actually tie it into a useful narrative or a useful set of activities. And after this presentation, which I think will be a little shorter than the Yang one, unless you really hammer on with questions, you will know how to get configuration from NetConf. You know how to actually configure things with NetConf, and you will understand how NetConf transactions work. I told you about this about Yang, and it's even more important here. I'm not covering everything that the NetConf protocol can do. It's actually large chunks that we just don't have time for. I believe that the full-blown version of this presentation will be on the order of 4 hours when we strive for completeness. So take this as kind of an intro for those of you who haven't heard this before. And there's quite a bit of other types of presentation material and tutorial material available, including, of course, all the way back to the source, the RFC. NetConf, of course, is a protocol. It's been around for a while now. As any good protocol, it's based on a couple of layers. I'm not going to spend too much time on this, but some of the terminology here is important. On the bottom, we have secure transport, very, very important, right? But we didn't want to build the protocol explicitly towards any particular transport, right? We had a couple of requirements on useful transports, and then produce what we call transport bindings. The majority of the NetConf implementations that I've seen in the world today uses SSH. So most of the implementations today is actually traveling over SSH, but that doesn't mean that it's inextricably linked with SSH in any way, shape, or form. Especially in the beginning, we had grand plans about SOAP and beep and all kinds of things. We may see, or we will see, actually I think we will see TLS coming, but for now, most of the actual deployed equipment runs over SSH. Then we have a messages layer. So this is, let's call it the envelope. It's the RPC reply style messaging that you've seen before. You'll see already here, hopefully, that this is actually the on-the-wire encoding for NetConf is XML, right? But that doesn't mean that you guys need to know XML. There's a lot of nice libraries. And there's also another NetConf-like protocol called RESTconf in the making, and we'll probably extend the tutorial to add that to where we have JSON. But for NetConf, we use XML. So you have the messages layer, RPC and RPC reply. Then we have operations. So NetConf as a protocol, and this makes it vastly different from things like SOAP, from things like HTTP, from things like beep. We actually describe a set of base operations. So we go far up the stack compared to many other things. So the next time people ask you, why do we use NetConf? Why don't we just use REST? You can tell them because NetConf is a full semantic stack with operations in it. REST is an architectural principle. You can probably implement NetConf-like behavior using REST, but it's not in REST itself. On the top, we have content. This is, of course, where Yang comes in, right? When we actually published the NetConf RFC, the first thing that we heard back was nothing, right? Because what's the fun of a protocol when you don't know what you're manipulating, right? So, of course, the fun starts with the content. In NetConf's case, it's the configuration data and also the notification data. We won't talk about notifications today, but the configuration data. And, of course, that's what we created Yang for, to describe the syntax, structure, and semantics of the content that travels in NetConf. A core principle of NetConf that it also makes it vastly different than many other so-called protocols is that we have the concept of data stores. I'm trying to use data stores when I can, not databases. We have the concept of data stores. There's 3 of them this far. We'll talk about capabilities. So this denotes a capability, which means that it's optional. But let's talk about all 3 of them. Of course, the running data store is what reflects what the box is doing right now. What that actually means in a router switch or base station depends a little bit on the vendor, right? It may take time for your newly changed configuration to actually happen on your firmware, but it's the representation of what the box thinks is its complete and active configuration. We have a startup data store. That's a pretty obvious thing. Usually when you want to snapshot or you say that this looks like a good configuration to have when I come up again, you copy the content of your running into the startup data store. So the next time your box cold or warm boots, it's going to read the startup configuration. A key thing that makes NetConf perhaps a little bit more interested, depending on your leanings, is the candidate data store. I think of it as a scratch pad. It's a global scratch pad, but it's where you actually start editing your configuration. And the cool thing here is that with the candidate data store, you can pre-validate. We'll get to that, but you can pre-validate the configuration without affecting the running data store in a well-implemented system. And of course, the communications between candidate and running is that when you're happy with your candidate, and we'll talk about these in more detail, you do what we call a commit. Commit means take the content of candidate and make it running. Very painful to implement for those of you who knows. And of course, you can go the other way around. So when you start afresh, you start a new session, you usually start by copying your running into your candidate. You manipulate that till you're done, and then you commit. Okay? It's important to have these kind of concepts in your head to really understand why NetConf may make sense for you or not. There's nothing particularly strange with a basic NetConf session. Like most RPC-based stateful protocols, they go through kind of three main phases. We start a session by exchanging what's called hello messages. We'll look at an example of this. The cool thing here is that the hello messages gives you capabilities exchange, which is also a little novel, a little new, I think, for network management protocols. Then you go on your merry way. You perform usually one or more operations. Great. First NetConf question.
Just one question. The data store is on the server or the client?
That is a fantastic question. It is on the server. Really important. So these three would be implemented in your favorite router vendor.
Okay. And another question, is it part of NetConf to discover the capabilities of the server, for example?
Absolutely. So that's what's going to happen in the first phase here. We do a very thorough capabilities publishing or exposure. So yeah, I'll show you examples. So you perform a set of operations, a series of operations until you're happy, and then you end your session. Of course, the well-behaved client would do a close session. The less well-behaved client would do a kill session, and the really rude would just tear down the transport, just kill SSH. It kind of has the same effect. So here we go with the capabilities, right? For every new session, the client starts with sending a hello. The client actually sends capabilities if it wants to. It doesn't make much sense, actually, in the real world, but you can send things like what NetConf version you support. The server then responds. This is a very, I don't have time to show you running code, but this is a very small response. This is usually fairly large. What this server tells the client here is that it supports NetConf base protocol 1.1, so the client knows that all the mandatory capabilities, all the mandatory functions in NetConf is supported by the server. It also says that actually I have writable running. You can write straight into my running data store, and I have a candidate. So this implementation actually has two of the three data stores that I showed you on the previous slide. Now the client knows, right? Down here, and for further study, the server also says, these are the Yang modules that I support. Think about that for a while. That's pretty cool, including the revision and how to actually get a hold of it. This means that you can always query a router for the exact contract language-like definition of the data set that you can manipulate on it. This has been sorely lacking in the industry for a long, long while. And before we move on, I'm going to bring in some
question.
Yes.
Features and deviations, are they exchanging the capabilities?
Features, yes. Deviations are in the Yang files that you look in.
Ah, okay. Okay.
Oh, they are? Yeah. See, this is great. They're also, okay, so the actual editor of the RFC said, yes, they're also advertised. So both deviations and features. That was close. Thank you. Should probably put that in the example. Okay, some terminology. So this is XML heavy, but bear with me. Okay, so in NetConf lingo, you remember this? This is the RPC envelope. Here are our operations. So in this case, we use the get operation. It's a basic NetConf operation. Operations have parameters. In this case, we use a filter. We'll make an example of this, but I just want to point out the lingo. Parameters may have attributes, so we're going to use a specific type of filter in this case. So operations, parameters, and attributes. So the first completely set up question is, how do I get all configuration and operational data? Day-to-day question, right? To do this, we're going to use two different operations. And this is also where NetConf is a little bit different than other protocols. We make a strong difference between the get operation that actually returns everything, both configuration and operational data. So if you want to have fun, you can take any big router that supports NetConf and do a get on route and watch it slowly keel over. It's a very, very heavy operation for most current implementations, because that means it needs to snapshot all counters, everything in its entire system. It's comparable to a single call SNMP walk for the entire MIB set. Okay, so don't do it yet until they got their code in order. The get config operation actually only fetches the configuration. So this is probably more useful. Typical use would be a backup. Actually, the semantics of this is such that you're supposed to be able to say get config, get the data, put it to the side, and at any point in time later, as long as the router or the box runs the same Yang models, you're supposed to be able to just dump it back. So we can say it's reliable backup and restore, much different from the way we've done it with CLIs and SNMP. Okay. So here's an example. All RPC messages have an ID. We actually use the base NetConf namespace. So namespaces is all over the place here. Nothing strange. You do a get. There's no parameters to get, which means you're doing the thing you shouldn't be doing, and you get an entire set of data returned in a data envelope. Okay, very straightforward. A more realistic, perhaps, get response. Actually, this comes out of our previous example. Is this? But it's a very made up too. It's as if this box only has two interfaces and only running IPv6. But as you can see, this data then is the same that we looked at for the example in Yang. Maybe the things to think of here is that this is where you start seeing the namespaces, right? This is the namespace from the Yang module for the IF types. This is the IETF IP namespace, and so forth. Okay, so of course our eager network person wants to know how to filter data instead of just get everything, right? So both the get and the get config operations have a filter parameter. There are two types of filters. There's a simple subtree filter, which I believe is actually mandatory. So it's a way of pointing out this is the path to which I want to see everything below that. For the more adventurous implementors, you can also have filter type XPath. And that puts you in a whole different situation. XPath, as you guys know, is a whole query language where you can do all kinds of cool stuff with existence tests and counters and all kinds of things. But subtree is mandatory. So in this case, we're going to use a filter to select a particular subtree and only get that. So here we go. We send the following message because we want to see just the interfaces list. So we have a get. We have the parameter filter type subtree. And what we're saying here is that we only want to see what's under interfaces. Okay. This is the, if you like, the subtree criteria. I should probably make it into one element. And here's the response message. And it throws back at me that based on the filter from this namespace, here is the only interface that I have. It's called ETH0. And if we do it on a leaf, you'll get some more data. So in this case, the full or the deep response actually also includes, of course, everything that's under ETH0. Okay. Okay, so that's that about getting, get config, and filtering. Now, how do we manipulate configuration? So in this case, again, we're going to borrow from our previous example. We're going to enable and configure IPv6 addresses for the interface. Two new operations here. Edit config is the big tool to actually manipulate data on boxes. So we're going to edit data store content, but you guys now know that there's 3 data stores. So we may need a target parameter to specify which data store am I manipulating at this point. And if we are manipulating the candidate, you guys remember that we need to also use the commit operation to take what's running in the candidate and make it running. So almost like a general example of edit config is this, right? It's an RPC, it's its own base operation. You point out the target, and then you send the config subtree that you want to apply to the target. So here's the actual payload to do what we did as an example in the previous, in the Yang session. So edit config, target running, right? So no candidate, just no candidate subtleties, just straight into running. We know what we're doing. Config envelope, and in this case, we know that what we are going to change is in the interfaces subtree, and this is the namespace for that under interface. For this to be actually valid, of course, we need to send the key. So we need to say that for this member of this tree, ETH0, make it enabled. Okay, so this is the edit config content to do what we mentioned in the Yang module. But that's too easy for our adventurous programmer here. He wants to use, she wants to use edit config on candidates. First of all, as I said, you have to check the fact that the box supports the candidate capabilities. You have to look in the hello message to see, does this box actually support candidate? If it does, here's what you need to do. First of all, it's good form to clear out the candidate. As I said, the candidate is global, so there may be lingering data in it that someone else didn't clean up after them. You edit the candidate so it looks like the way you want it to, and then you commit it, again, which means that you move the content of it into the running data store. Yes?
How do you deal with race conditions for that?
You take locks, and we'll get to that in 5 slides. Oh, good. 2 people just running up. That's fine. Maybe I'll make just a small note. Sit on your hands, race conditions later. Delete config, the parameters target and candidate. We do edit config with the target candidate, new configuration, and we commit. That's the very short one. Yes?
Sorry, question about the edit configuration. So when I use the edit configuration to configure some configuration to the servers, do I need to use the get config first? Because when I add the configuration, maybe the configuration of the server may be changed. So better I need to first get the configuration and then add the configuration to the server.
I think it's safe to say that in most real implementations, you would do a get config
so
first.
This is not the protocol declaimed. This is the implementation defined.
Yes,
oh, yes,
exactly. So but in realistic systems, so like the ones that we have,
from the point of view of the protocol, do we need some mechanism for to guarantee that the consistency of the configuration between the client and the server?
A good implementation would provide that, yes. But actually, from the kind of NetConf and Yang perspective, we are more concerned about the consistency on the server.
Okay.
See what I mean?
I see.
Yeah.
Yeah. Okay, thank you.
Also, can I do anything like wildcards? So on the previous slide, could I do like interface star enabled true, or do I have to?
So I'm going to glance over and say in subtree you can't. With XPath you can go crazy on it. Yeah. So here's the edit config, our first step in that 3-step thing. So we had edit config, target candidates, same content that you saw before, and then we commit. That's the basic difference. And the commit step, if I didn't mention that before, is, of course, a transaction. So when the box returns that your commit was successful, it is supposed to be successfully running in running. If something happens while applying it, you should have your candidate intact. And you can use other things like validate or change what you have in your candidate and retry. Okay. Now, 3 slides. That's what it was. Locking. I don't want others to change the configuration while I'm editing it, right? You don't want bad fallouts from race conditions. We'll use a couple of new things. Actually, we're getting closer to kind of a full set of operations that will give you two-phase commit-like transactionality. The new operation here is that we will use a locking operation. You've seen delete. No, you haven't seen delete config. You've seen edit config. You've seen commit. And then, of course, to close it off, we will unlock the databases that we needed. So here we go. A good gentleman will then log in, or in the first thing to do in the session is to lock. So we have a target here. Of course, you don't want to lock the entire thing. In this case, we want to lock the running. Now, next question from you guys will be fine-grained locking. And no, there is no finer-grained locking than on a database level. Don't give me that look. Say something. Huh? In the base protocol. There are extensions, but in the base protocol. Good point. Delete the target candidate, so we clear that out. We do the edit config on the candidate. We commit it. Then we unlock it. Shouldn't say free, should say unlock. Data store. Here we go. Yes.
So another question. Can you sort of commit it and then require that you approve it sometime after that? Kind of like Juniper's, commit on a config.
3 more slides. You will find that Juniper did have quite a say in the creation of the NetConf protocol. Validation and rollback. In this case, we will use a new operation called validate. So we will validate the content of a data store, which means that you will ask the system to do whatever it can in the backend to make sure that, first of all, it complies with the Yang, but maybe also other stuff, right? Is the temperature in the chassis such that you can do this change? And then we're going to use something called a confirm commit. Now that's a hint. That's called confirm commit. Confirm commit is a particular type of commit. There's 2 new parameters that we're going to talk about here. One is a persist parameter to specify a commit identifier, so a unique identifier for a particular commit like you can use later. And the other one is a confirm timeout. So what confirm timeout means is that unless you're back to confirm the confirm commit, what we call a confirming commit, the box itself will roll back. Okay, so if that times out, the box will roll back itself. You can also cancel commits by identifying your commit using the persist parameter. So the validation step, because we've already done the edit candidate here, looks like this. So this is the way of asking the box, take a look at what I have in candidate, and the way you feel about things right now, is this valid according to Yang and according to your running state? If this is okay, then you can proceed to the commit state. And here's the confirmed commit. So the new things here are the parameters. We have the confirmed element. We are sure that, if something goes wrong inside of the next 10 seconds, it needs to roll back. If it survives 10 seconds, we're fine. This would have saved me in 1998 from taking out half of Sweden, for example, by mistyping ACLs and locking myself out of some core routers. Because had I done this with a confirmed timeout, I couldn't come back and confirm the commit. So it would have rolled back and saved me a crazy car ride. And in this case, we also send the persist ID. And here's what the confirming commit looks like. It's a commit like any else, but you send the persist parameter here. So that means that you can forget about the timer. You're now can forget that state, and you're running. Okay, we're getting closer to the final crescendo here. It's configuring multiple devices. So in this case, our network engineer wants to configure multiple devices at once and roll back everything if anything fails, right? So you set up a VPN, If anything fails on any of the participating boxes, you want all of them to reliably come back to where they were before I started meddling with them. Same steps as in the previous example, but we will do it in parallel with one stop along the way. So this allows for two-phase commit transactions over network devices, given, of course, that devices you work actually has the capabilities that is required for all these steps. Great.
When a failure occurs, can you have that from a different channel and say, oh, I noticed a failure and notice there is a failure, or?
Ooh. So let's say you have an alarm system on the side that suddenly gets a trap.
Probably, yeah.
There would need to be some sort of a channel between that alarm system and whatever client is actually doing it. See what I mean? There's no way for you as a third party to come in and say, stop what you're doing.
Okay.
Unless you know of the transaction ID, actually, then you can go in and say, yeah. It gets intricate. Okay, so here's the prepare phase for you, for the people with some database background. So 3 devices, right? Step 1, prepare. And prepare in this case means that you lock everything, clear the candidate, edit the candidate, and then you validate, right? So now you know that the content that you have in the candidate is validated by the box. So that's a traditional prepare phase. All the subscribers or all the members in the transaction have said, what you're telling me looks good, okay? If any of the devices here say, well, you just gave me garbled input, you can just empty the candidate and unlock the data store and go back and think about what happened, okay? So nothing has actually been done to the running data store yet. But again, the devices have told you that what you're asking me to do looks reasonable. And then you commit. So then you probably do a confirm commit here, because of course, while the data that you send to the box will be syntactically and structurally valid, it may be wrong, right? You may have the wrong BGP parameters, so your neighbor doesn't come up. You may have the wrong VPN endpoint, so there's no data flowing, right? So between the step of a commit and a confirming commit, you can go ahead and do whatever burn-in or feature tests that you need. So you will have a timeout that is appropriate for whatever you're going to do. And if any of those fails, if something, there's no carrier Ethernet, the inter-frame delay is too high, so this is not going to work. All you have to do is, well, if you're rude, you can just kill the session, because a killed session on a confirmed or commit actually means rollback. And you just kill the sessions or close the sessions on all devices, and they will reliably roll back. So you're back to where you were. If they all work, then you can reliably just confirm the commits and then unlock the data store. So this will formally protect you from the common mistakes that we all do, in the sense that it provides two-phase commit-based transactions. Any questions? Did you catch that I looked unsure when I said that? Because I'm not sure after persist, I'm not so sure. If you have an open session with an outstanding commit, and you kill the session, does the box roll back? Yes.
The question is, does it unlock? So if you just went ahead, you locked it, right? You did this commit, something failed.
Yeah. Okay.
And you said just kill the session. While you're sitting there with lock.
It also releases the lock.
It does.
Yeah.
It does. Okay.
Yeah. That one I was very unsure about. Thank you, guys. Any other questions? Because this is my last slide before I conclude that you know everything about NetConf.
This is probably more of a deviation, but what about how does NetConf interact with other elements which may configure a switch, right? Because I have controllers which manipulate ARP tables, and if you're telling me that I have to lock something and then wait for that, it's kind of screwy.
Yeah. That is a universally challenging thing, and it's not new for NetConf or for Yang for that matter. It's a tough thing. What Kiriti said, don't use anything else. Yeah. It depends. So from observation, because the company that I work for used to sell NetConf servers into people running or building network equipment. There are two kind of ways of going about it. The one is to take the step and say, look, the NetConf server actually owns the data, right? So everything that happens to that data needs to be conformant with Yang. That's for clean slate implementations, to put it mildly, right? When you have a green field. The other one is to actually try and separate them based on what is it that you want to do. So you have netconf for certain things, and then you have the others for other things, and you hope that there's no interaction between them.
Yeah, because the netconf for everything won't apply because it seems the timescale is very human operator focused, right? So you won't get a turnaround fast enough. So an example
for netconf or for?
So an example I have is that we have software which effectively manipulates the ARP table based on local health checks. I'm not going to do the entire time frame of streaming something up centrally to then have something configured back out, right?
Yeah. So what you would normally do, that's a good one. So what you would normally do is actually declare that operational. So you wouldn't even meddle with that through netconf. See what I mean? Yeah. Record holder.
There's a similar thing with routes. We have static routes which are done through netconf, and BGP routes that are not done through netconf. And exactly what you said, timescales, it's dynamic and so on. And they're separate. So I don't know if you call the BGP routes operational. You can read them, but you definitely don't configure them. Any routes that you configure are static routes. At least this is how we work.
Yeah.
So there is also another working group called the ITRS working group, Interface to Routing System, and their intent is to support ephemeral configuration with a very high rate of change. So it's sort of a short circuit through the netconf path, but it's still Yang model data.
Yeah, it's a third type, right? Config, non-config, or operational and ephemeral. Yeah, it might be appropriate as a sort of a concluding remark is that, again, and thank you for your patience, this is a pretty basic and straightforward tutorial style presentation. So don't take away from this that we're not doing other things. We are doing a whole lot of other things in the IETF, both around protocol developments and certainly around the Yang language itself and modules. So this is the entry level welcome to NetConf kind of presentation. And of course, you are all now able to obtain configuration, configure network devices, and explain to someone how NetConf transactions work. How am I on time? Yeah, officially dangerous. You can now shoot yourself in the foot using two-phase commits. If there's no other questions, thank you guys. That's it for this time. And no, wait, here's what we want to do. Here's what we want to do. We want to send the link to the evaluation, don't we, for the edu team? There is one, yes, yes. How do we do that? It's pretty pointless to put it up on the projector. There is an evaluation link on the agenda for this item. Please, again, the usefulness for me is if you guys rip into what I just did and help me make this much better so I can iterate over the content many, many, many times. Go ahead.
And do we have your slides available?
They will be good one. They will be available at the same place that the evaluation link is at.
Right.
Good one. Yes. Thank you. Thank you. Very nice. Well set up. Thank you, sir. Okay. If nothing else, thank you, everybody. Thanks for coming.